Welcome to the Deep Dives. We cut through the noise, get you the key insights, and today we're really plunging into energy storage. It's vital stuff, our mission. Let's unpack where our energy future is really heading and, why it should matter to you.
Yeah, and what's really fascinating, kind of right off the bat, is the IEA's 2023 forecast, the International Energy Agency. They're signaling this, monumental shift. They actually project all fossil fuels peaking before 2030.
Wow, all of them. Before 2030.
Think about that. Their share in the global energy supply expected to drop pretty significantly, down to 73% by 2030.
Okay, so this isn't just about, hitting green targets then?
No, not at all. It's way bigger. It's a huge rebalancing of global power, really.
Yeah.
Shifts economic influence, national security. We're only just starting to, grasp the scale.
Right.
And the money follows, doesn't it? Clean energy investment, it's surged 40% since just 2020. And get this. Over 500 gigawatts of new renewable capacity expected in 2023 alone. Record-breaking.
Okay, so this is happening right now, not some far-off thing. And that, for me, really shines a light on energy storage.
Yeah.
We used to think maybe batteries and phones, small stuff, but you're saying it's now crucial on a much, much bigger scale.
Absolutely. Utility scale, behind-the-meter storage, it jumped 90% in 2022 alone.
90%.
Yeah, and that's just essential if you want to balance renewables like solar and wind because they're intermittent.
Right, the sun doesn't always shine.
Exactly. The IEA even has this scenario, the NZE solar case. Net zero emissions for solar. They see utility-scale battery deployment nearly doubling by 2030.
Doubling, okay. And a lot of that's been lithium-ion, hasn't it, since around 2014?
Precisely. Lithium-ion's rise has been, meteoric, driven by production costs falling and, of course, the EV boom.
Electric vehicles, yeah.
And Bloomberg NEF, their 2023 survey, it showed lithium-ion pack prices hitting a record low $139 per kilowatt hour.
$139, okay. That's despite demand going through the roof.
Demand was up something like 53% year on year. Huge growth.
So, okay, prices are falling, demand is soaring. But is there a catch? Can we actually get enough lithium? Could that slow things down?
That's a really excellent question. And yeah, despite the falling prices, the supply chain is definitely a concern.
How so?
Well, you've got the surging demand itself, challenges in actually extracting the lithium, the costs of materials creeping up, geopolitical stuff. It all adds up. These things could definitely put the brakes on that rapid cost decline we've gotten used to. It kind of reminds us, there's no single silver bullet here.
Right. So if lithium, our current superstar, might have issues, what's plan B? Or plan C, D, E? This is where it gets really interesting, I think. And actually, it's partly why we developed our own little index for this deep dive, the Will It Change Everything score. We call it WICE.
Yes, WICE.
Yeah, it helps us look beyond just the tech specs and the cost, right? To see what really has disruptive potential.
Exactly. WICE looks at scalability, environmental impact, how sustainable the material sourcing is, even policy alignment, the whole picture. The goal is to pinpoint technologies that could really accelerate this whole transformation. Just for context, lithium-ion, it's super mature, TRL9.
TRL9, yeah, top level.
Right. So that sets our baseline WICE score at 60. But the real takeaway, looking beyond lithium, is needing a diverse portfolio, a whole toolkit.
Like building a team, you need different players for different jobs.
Yeah.
Makes sense. So what are some of these alternatives making waves?
Exactly that. So think about gravity storage. Sounds basic, but it's clever. Using elevated weights, even old mine shafts, for long-duration storage.
That's revy.
Then you've got flow cells, like vanadium redox flow batteries, VRFBs. They store energy and liquid electrolytes. Super scalable. They last ages 20-plus years, and they're very safe.
The liquid ones, right. Heard about those.
Then there's things like compressed air energy storage, CEES, and liquid air, LAES, good for grid scale stuff, or flywheels. Storing energy in rotation. Really fast response, great for grid stability, super efficient too, like 85-95%.
Flywheels. Wow, okay.
And of course, totally new battery chemistries, things like sodium-ion, zinc air, trying to get around those lithium material concerns.
Okay, so it's clear they all have different strengths, yeah. Scale, speed, how long they last, seconds to months potentially.
Absolutely. And it's one thing talking theory, but seeing it happen on the ground. Take the Danube region in Europe.
Yeah.
What's happening there?
Well, countries like Germany, Austria, Czech Republic, they were in the top 5 European battery storage markets last year, 2023. Between them, they accounted for something like 82% of all new EU installations. Massive growth.
82%. Okay, so they're really leaning into this. That must tie into the EU's bigger climate goals. For sure. It aligns perfectly with those targets aiming for at least 55% greenhouse gas reduction, 42.5% renewables and final energy use, both by 2030. You just need that storage for grid flexibility when renewables are projected to hit, what, 69% of the EU's electricity by then?
69%. Yeah, you absolutely need that diverse toolkit we talked about.
Exactly.
So wrapping this up then, what does it mean for you listening? I think the takeaway is the future isn't one single answer. It's got to be a smart mix. We're building this resilient, sustainable grid with a whole portfolio of storage solutions.
Yeah.
And hopefully our WICE score helps point towards the real game changers.
Yeah. And maybe a final thought to leave you with. What's the next big aha moment going to be in energy storage? How quickly will these alternatives really start reshaping things, pushing us towards that greener, more stable power system we need? That's the big question, isn't it?